Okay, we're live. And I'll start screen sharing. There we go. So that's the first one.
And that's the prep work?
No, this is the what do you call it?
The extension problems?
The extension problems, yeah.
Okay.
Yeah.
So these are the answers that we were supposed to have, or that we were given and we thought about on Tuesday.
Possibly. But does this make sense what I'm doing here?
So why on x plus or x minus 1 equals 2x plus 7? Why did you not just add the 1 over and get plus 8?
Did I not do that? Or maybe not.
I guess you did, but what happened to your 2x? Did you just divide the 2x out?
Did I? Did I mix that? I think I did.
So you subtracted the wait.
No, that would still be.
No, yeah, I think you had it.
Maybe that's why that was negative.
But why does x equal negative 8? Oh, there it is. Okay, that's why.
Yeah.
Yeah, so you basically just did the log function, then you put everything in log 3 and made the exponents x minus 1 and 2x plus 7 the base of the equation. Yeah, makes sense.
It was just a log 3 over log 3.
Yeah. The log pulls that exponent and puts it in front. So same thing here. So yeah, when you take the two logs, you divide 16 by 2 to get that 4. Everybody good?
Yeah.
And then I didn't get any solution for this. I even tried graphing it, and he's like parallel. Don't cross. So I don't know if you guys have any other idea of how to do it.
Not a clue. What does it look like when you try to graph it?
Let me show you real quick. Do y'all see that?
Mm-hmm.
Yeah.
So these are the two graphs that are represented here. And they just keep going and keep going. And they just never touch. So that would tell me that there's no solution.
Yeah, that makes sense.
So then I got to here.
So this one would have to be 0 as well. Or no, it's not as well, just 0.
Just 0, you say?
Yeah. 'Cause that's the only solution. Oh, and 1. No, yeah, 1 wouldn't work.
Yeah, I'm thinking that too. We can check in this graph to make sure. Anyway, I think that's what it's supposed to be. It's not working.
I've almost got it.
You almost got it?
Yeah, in a calculator.
Oh, the graphic calculator, right?
Just to see what they look like.
And in this one, you can't have negative numbers, right? For your solution. Or can you?
Hmm.
I'm not sure. I was just asking. I remember hearing that at one point in time, but
For the log of 3/2, it does not go negative. Or the first one, I guess. 2x plus 1.
Oh,
But
wait a minute.
because it's x squared plus 1, it goes positive either way. So it can go negative. Yeah, the zeros are 0, 0. So
Interesting.
uh-oh. What's up?
nothing. I just liked that you said, uh-oh.
Well, we lost one of our guys, James. He just poofed.
You just pooped.
Poofed.
Oh, I said pooped. I was like,
No, he poofed. So this is what I got for the graph. There we go.
Yeah. Yeah, so it looks like there's another intercept.
But for both of them, they both cross x when both cross x at 0, 0.
Yeah.
Well, this is what I got when I graphed it. I used a website thing. And then never touched.
For the second one or the first one?
Log 3/2 x minus 2, and then x squared plus 1.
I mean, they touch a 0.
No, because this is one graph here, and then this is the second graph is what they've done. Because there's a green one here, and then the blue one here.
Are you talking about the graphics on Chris's page?
No, on my page.
Oh. I don't know if x equals 2 is an answer.
Yeah, I don't think it is. That's a graph series. Maybe not, though.
Yeah, here's the graph that I got.
Oh. The first log is 2x minus plus 1, not x minus 2.
Oh, that's probably normal then. Might be.
So my graph is showing. Oh, it's
minus 1.
plus 1.
Are you guys getting weird echoes today?
Yeah, I'm getting a lot of echo.
Echoing. Nonsense.
Let me go find my headphones.
Okay, yeah, you guys are right. It does cross then. So it crosses here on 2 places at 0, 0, and
2.
that one.
That's why I was saying 2 might be a solution, but I'm not sure.
So it's here's for this calculator. This is what it says: 0 is true and 2 is true.
So it is 2.
Alright. Found him.
All right, number 2.
Graph the following functions by identifying all the transformations. Do not forget that you need to include the growth/decay transformation. Do not forget the vertical and horizontal asymptote on the graph. Also, identify the domain and range.
Awesome. We should do these as quick as possible so we can get onto that quiz.
Yeah, because I actually don't know what today.
Should we just do the quiz and then come back to these two? Since
Yeah, that sounds good.
We've done a lot of those ones, so. Is that the quiz?
The quiz.
Yeah.
Oh,
This
nice.
is the quiz. Mm-hmm.
This is logarithm.
Logarithm is ...
Hello. Oh.
So in Google, it says logarithm is a quantity representing the power to which a fixed number must be raised to produce a given number.
That makes sense.
You could probably just copy and paste it from Google on your screen if you wanted.
That's probably a good idea. Smart thinking.
Well, what does that mean?
Let's go back. Um, um,
So in order to get an answer,
You have to put numbers in.
Yeah. No. You raise your equation by a certain number, in which case that would be the base. Meaning that in order to get the quantity that you need, you have to raise the equation to a certain power.
So I looked on Google and they gave an example of log 100 equals 2. And that's because 10 squared equals 100. So your squared is the power or the quantity. So 2 is your quantity because it's the power to which a fixed number, in this case is 10, must be raised to give a number. So 10 squared equals 100. Does that make sense?
Oh yeah.
There we go.
It makes sense in this thing. Do you want me to screen share it so you can see it, or?
Yeah.
For all those people who aren't getting it, you know.
No, you're good. So right here, it's kind of what the top 2 dots.
Oh, because 10 is the natural log. That's right. Yeah.
Yeah, so 10 is your natural log. 2 is your number that it's raised to in order to get your base number of 100.
So it would make worse.
100 is basically saying what power should you put 10 to get 100, and that's 2.
Yeah, but that can really be any number. So like 64 would be log 2, and then your base number would be 8.
Okay.
Yes, there should be a number between log and 100, like a base. But if there's not one, you assume it's 10 because that's the natural log.
Yeah.
Okay.
So, yeah, so what number do you have to...
Like the second example on that page is log 2, 8. So would 2 be the base?
3 is your base, I think. No, that's your power that you have to raise 2 to in order to get to your 8.
Okay, so 2 would be the base.
So you have log 2. So it's saying how many times do you have to multiply 2 in order to get 8? And that's 3 times.
Okay.
So 2 times 2 times 2 is, 8.
Yeah.
Right?
Yeah.
Yeah.
Okay.
So that makes sense to everybody?
Yeah.
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 So we can keep explaining it, if not.
No, that works. That's what I needed.
Alrighty.
Logarithms and exponential functions are inverse function. What does that mean? I'll kind of explain that. So in a logarithm, you don't have the exponent, but you have the answer and the base. It's your job to find the exponent.
And then I guess the exponential functions, it's the opposite. You have the exponent, but you don't have the base.
Yeah, exactly.
So how would you write that?
You have the base and the answer, I guess. Result.
Yeah.
And in expo, and you power or exponent. What was that?
Looks good to
Works
me.
for me.
Find the inverse. Bum, bum, bum.
So that's log base 3 of 2x plus 4.
That sounds good to me. Yeah.
And then what do we do with this one? Please.
Oh, plus 3 too. Can you really do anything? Can you simplify that more?
I don't think so.
That's all they want us to do.
Mm-hmm. We might want us to add f of x equals.
Yeah, that's what I was just thinking.
Yeah. Alright. Sweet. Solve equation. Find exact solutions. Alright.
Oh my gosh.
Stupid. Well, x equals 0, right?
Yeah, because you're trying to find what power is going to give you 4 to the power of blank equals 0. And 3 to the 0 and 2 to the 0 is 0 because 0 is everything. Is someone trying to graph that?
No, I was just trying to verify. Yeah. I'll try to guess that.
Well, if you were able to verify it, then I don't see why not.
There's no answer.
Let me see about
Because
this.
it errors at 0.
Mm-hmm. 4 of on base 3 and log base 2 of x equals 0. No graph. Hmm.
Was there no solution?
No, there must be something. Oh,
Is it
that's
log
probably why.
base? Is it log base 4 or is it log base 10.4? Log base 10.3.
Let me check. Actually, that's a good point.
I put that in and I got no answer for 0.
It is log base 4.
Is okay.
Draw bases.
Pretty sure there's an asymptote at 0.
Pretty sure you're right.
Nope. No asymptote because it crosses at x equals 8.
So it must be 8 then, yeah.
Mm-hmm. Double check.
Oh, that's what I did.
One
No.
Wait. Eight. Yep. So how'd you get 8 on your end?
I just typed it into one of those.
Online calculators.
Are we just verifying it right now?
Yeah, so it's 8.
So the answer is 8.
Yep. Mm.
Did you guys see that we got a 50 on last week's group quiz?
Did we what?
We got a 50 on last week's group quiz.
I don't know how. I thought we did everything right, but
I mean, I always do think we do everything right, but seldom is that 100% true.
yeah.
The TA sent out the reason why we got a 50%.
Yeah, I mean, she showed us why we got the 50%, but I mean, I don't remember exactly what we did for that problem.
Yeah, I don't either.
So, I mean, even when she showed us what was supposed to be done, it's kind of hard to see what we didn't do.
Yep.
I just kind of wish the teacher would at least like do one video thing with us to teach us how to do it each week. That'd be nice.
Yeah.
That's a good point.
Hey, Sal is just as good. With logarithms, like I know she doesn't want us to use a graphing calculator, but like with logarithms, are we allowed to start graphing these so we can know what to do?
I do not know.
So how would we? I understand how we did it in the extension problems, but how do we do it here? Because we don't have an inverse equal to an inverse. You can't just divide it out. Do you know, Chris?
I can't figure it out.
And that's what it's called, right? An inverse? Or is it called something else?
What are you talking about?
Talking about
Like-
being.
I'm at the opposite of a log expression.
Yeah.
Yeah, it's the inverse, which is exponential. So for this one, wouldn't 4 be the base? Okay. Wait, is there any reason why we can't hear Chris?
I think he's just pondering on the things of eternity.
All right.
Pondering on the things of eternity.
Hello? Oh, there we go. There, I'm back. I don't know what happened.
All right.
Chris, you're back. We missed you, man. I was just seeing numbers change, and I was like, I hope that's Chris.
And not a cat or something.
Oh, gosh.
So, can you explain how we did that? Because I know how we did it in the extension problems where we had inverse sets of inverse and we can divide it out. But on this one, it's equal to 8. So would you just have to figure out what the log of 8 is, or the inverse of 8 would be?
You can divide the logs and get rid of them, and 8 divided by 4 should equal 2. Why does that equal 1.5? I don't know. That's what I thought, but maybe not.
So on this one, you just said x minus 2 is equal to log of 4 or log of 9. 9 divided log of 4. No. Yes.
I'm trying to make these all consistent. Okay. Wait a minute. Maybe it's more than I thought it was. right. That's right. I think it may be more than simply just dividing this log. I think log of 9 in and of itself is a number.
We're allowed to use a calculator, right?
Yeah.
That's why log of 8 over log of 4 equals 1.5.
Yeah, that's why that is
Yep.
what it is. Let me try something. Log of 4. Log of 3. Log of... Oops. Log of 2. X. What the heck? Apply log rule. What? Can anybody make sense of this?
Well, there are log rules. I just don't remember what half of them are.
Same.
Let me see if I have it in my notes. Ow.
Sorry, guys, I had to go get something quick.
All right.
Oh, shoot.
Whoa.
That's pretty cool.
Hey, one does that.
Okay.
Super trippy, dude.
So then in B and C, what you just did is you found to get the x minus 2 as the base, you had to divide the log of 9 by the log of 4. And our actual numbers, like the log of 9 is equals an actual number divided by the actual number of log of 4.
Yes, so log of 9 is a real number, is an actual number, and log of 4 is an actual number as well.
Okay. Sounds good.
The question is, what is A?
Oh, Chris, were you able to listen to us, or could you not even hear us either?
What did you guys say?
Oh, I just mentioned that we got a 50 on last week's group quiz.
Oh yeah, I heard that. I don't know why.
Yeah. Totally dumb, right?
Yeah, I don't know.
So for this one, how on earth does it, and how do you find this on our calculator? So to find the log of 4.
Calculators usually a scientific calculator will usually have a log button.
Oh, okay.
Yeah.
Oh, I just found it. Never mind.
Yeah. What the heck?
Why did they? Okay, I don't know.
Apply log rule.
I'm just like looking at these numbers and I'm just soaking it in.
Okay.
At least you're soaking. It's just kind of bouncing. I've been trying to figure it out for a while.
Seriously. This makes no sense.
How did it go from log 4, log 3, log 2, x equals 0? How did that 0 suddenly just transform himself into log 4, 1?
That's what I want to know. It appears that there's some log rule that tells you can do that.
Well, the log rule, it says A equals log B and BA. So log B would, well, no, because I'd assume log B would be 3. I'm just assuming the numbers, you know what I mean?
Yeah.
For 4, 3, 2 would be B, and A, and C, but
So right here it says when the logs have the same base, log b of f of x equals log b of g of x, and then that goes to f of x equals g of x.
Right, but we're not figuring out why any of them have the same base. Like, why did the 0 for them to have the same base? That 0 in the beginning has to turn into a log.
Right above where they do it, it says log of 4, log base 4 of 4 to the 0. So anything to the power of 0 is 1.
Yeah.
So that makes sense why log base 4 of 1 is because 0 equals log base 4 of 4 to the power of 0, which equals 1. You're taking the log base 4 and putting the 0 as the exponent from.
Okay.
I can read it off to you if you want, so you don't have to keep swapping back and forth.
Sure.
Alrighty, so it's log 3, parentheses, log 2, parentheses x,
Yeah, parentheses X. Yeah. Oops.
and then closing parentheses for all those. So 2 closing parentheses equals 1.
Uh-huh.
And then they break it down into applying the log rule again, which equals log 3, parentheses log 2,
Ugh,
I just copy and paste the one above it. It's basically the same.
that works.
And then equals log 3, parentheses 3.
Because you're taking the base of 3 and putting it to the power of 1.
Oh, so I think this is just trying to get rid of the logs then. So basically applying the log
Yeah.
rule, all it's doing is getting rid of each log individually. But I don't know where they're getting their numbers from.
They're getting their numbers from the base and the base and the number inside the parentheses.
Okay.
So with the rule, you put you have b as your base, and b is the number inside the parentheses, and then you put a
And that
as
is
the
just getting rid of the
power.
log. Gotcha. So it's just basically putting each number in to try and get rid of the logs one by one.
Yes.
Okay, so now it's log 2x equals log 2, 8.
What?
Log 2, parentheses 8. Well, I guess it's 3, sorry. Log 2x equals 3.
Mm-hmm.
And then
And then it's log 2x.
log 2x
Equals log 2, 8. And then it
8.
says when the logs have the same base, then you can just basically cancel out the logs, and so x equals 8.
Makes sense. Okay, that makes sense. Explain to me. Okay, this makes sense right here because you can cancel out those two. So where did we get this log 4 to the 1? That just does not make sense to me.
So it came from the 0.
Yeah,
So-
because when you did the 0, all it did was take the log 4. So apparently what I'm understanding is applying the log rule is just allowing you to equal the other side so you can continue to cancel out logs.
Yeah.
And so when it equals 0, they just did log 4 to the first power, and then that got you down to 1.
No, it's
And then they did
power
log
of
3 to the third power type of a thing, and they just kind of kept going down to get rid of each logs.
So it was log base 4 parentheses 4 to the power of 0, which equals 1. Then it was log base
No, it doesn't
3.
just equal 1. It equals log base 4 to the power of 1.
For log base 4 and then parentheses 1. Yeah, that's what I said. Where 4 to the power of 0 equals 1 inside the parentheses.
That makes sense. Oh.
And then you take whatever the base is, you put that inside the parentheses, and you take the last number you had and put that as the exponent. That's why log base
That makes
2.
sense.
I'm just wondering where the 8 came from, though. How did they get 8?
The 8
See,
came from
right,
2 to,
first you have
2
log
to
2.
the power of 3.
Oh, 2 to the power of 3. Gotcha.
Yeah.
2 to the power of 3 equals 8. Gotcha.
Get rid of that. Okay, trying to clean it up a little bit.
I think it looks good.
I think it looks good to me.
Mm.
And then you already did the other 2?
Yeah.
Nice. Okay.
So I guess I just have that one, these 2 to do.
So it stretches to the -3 and reflects over is it the x-axis?
Yeah.
Goes to the right one and something happens with that x minus 2 in the exponent. It's a good question.
And right 3.
It goes to the right 3?
Right 2. Right 2. F1 for sure. Doesn't it go right 2?
Can you do an exponent as the transformation?
I don't know.
I don't know either.
Yeah, I think that doesn't affect the graph. I think that just affects the parabola part of it. I don't know. Yeah, I'll do it to see if we got it right.
Oh.
We could put the domain in and the range would be 1
Yeah,
to
it
infinity.
goes to the right too.
And I'm guessing it's decay, but I'm not sure. Yeah, it's decay. This is negative.
Yeah.
There's a vertical asymptote at -3, right? Maybe not. Oh, +1. There's no horizontal asymptote. I do not think.
Well, why is there a vertical asymptote? Because to get a vertical asymptote, you'd set the denominator equal to 0.
Is there not one then? Perhaps there's not.
Nope, it just goes on forever.
But I think there is a horizontal asymptote. Actually, an asymptote is where the graph cannot exist, right?
No. It's a line which the graph cannot go above or beyond. It gets closer and closer and closer, but never
Horizontal
can.
asymptote is 1.
See, that's what I thought that was the case.
Well, see, I mean I thought it was 1, but then if you follow the graph long enough, it does hit 1.
Right, but it doesn't go above that.
It won't
No matter
ever
how
go
far you
above it.
go.
Okay.
And the range, oh yeah, so the range would be
1 to infinity.
gonna
Or
be
negative infinity. Sorry.
Or negative infinity to 1.
yeah.
No. Wouldn't it? Wait.
I thought
Uh,
lowest number and go to the highest number.
yes. That's right. I was thinking domain for some reason, just the other way.
Yeah.
Yup. Oops. I'm gonna fail this exam. I'm just kidding.
This is going to be my 3rd exam this week.
Oh,
That's always
fun.
fun.
The first one was a macroeconomics exam, and I got a 74, which is average. It's like exactly average. And then yesterday I took an accounting exam, and I got like an 84 on it. So I'm on the uprise. Hopefully I do well on this one.
Keep increasing with each test.
Hmm.
I wish it was a group test, you know?
Mm-hmm. I'm still down for that one. Totally wish we could.
Oh, right. 16. Or maybe not.
So does the logarithm of a graph affect, like, does it make it have a parabola or anything like that?
Wouldn't it's just like the last graph.
So for this domain, I got -1 comma infinity for it. And then the range, I got -infinity and infinity, and this is just from Symbolab. So I'm trying to figure out how to do these.
Yeah.
Because me just staring at you guys typing stuff in isn't really helping me too much.
You're good. Okay. See, that makes sense because there's a vertical asymptote, so that makes sense that this would be -1 and not this. Or if it was horizontal, it affected the range. So that makes sense to me.
Yeah.
Two times 1/2 ln of x plus 1 minus 3. Okay, that makes a lot more sense. So we have stretched by 2. By 2. You have a left 1. Down
Reflection
3.
over the x-intercept or x-axis. Yeah.
I think
And then here's
that's
the graph if it helps anybody.
Yeah, decay.
yeah. That red line right there is the asymptote.
Yeah, it's vertical, so there's no horizontal then.
Nope. And it's decay. Yes. Because that 2 is
Is
negative.
this one decay or is it in? Because doesn't this one move to the right?
I think it's.
I thought it was growth.
Did you put the
So I
negative
thought you always
in
read
front
graphs
of the
left to
2?
right. So wouldn't that be growth from here?
Did you put the negative in front of the 2?
Yeah, that's what I thought. It was the negative in front of the 2 that made it, or negative or positive right there in front of the 2 that made it growth or decay.
Oh,
That's what I thought.
you guys are probably right. Oh.
Do we need to graph? Yes, we need to graph them. Dang it.
Well, here's you want the graph again?
Yeah, let me just put some room for it. This one was for the -3. Yeah. Hold that one. Do that one first. This one. Okay, I got that one. Three. Here's 3. 4 to the x minus 2. This is a plus 1. Got that one too. What the heck? Oh. Okay. I think we're done. Anybody have any further questions?
I do not.
Nope.
Nope. I think I'm good.
Okay.
All right, guys. Well, I gotta start getting moving forward.
Okay.
All right.
All right. See you later.
Peace out.
See ya.
All right. I'm heading out. We'll see you on Tuesday.
Yeah, Tuesday.
See you, everybody.
All
See
right.
ya.
Bye.